Yeah, greetings, good people. My name is Edwin Ramogi. I am a member of Bright Minds Group, and I am going to take you through a brief presentation of our proposed system, which was to come up with an IoT automated weather system. In my presentation, I am going to look at the overview of our system and the scope of our problem, which was to collect, display, and store weather parameters to be specific within African Nazarene University. The proposed system was supposed to be active 24/7. It was supposed to be cheap, efficient, and secure. So these are the motivations that led us into coming up with a proposal for the system. The system was supposed to enhance experiential learning for climatology students. It was supposed to provide the ERM department and the university at large a personal weather monitoring system. It was supposed to allow future weather predictions through the continuous 24/7 weather data collection. The expected outcome of our system, which we all decided as a group to call it NAS weather, was to allow for collection of data through a sensor, was to allow.
Hello, I'm Brian. Just to finish up on what Edwin was saying, the expected outcome of our project is NAS weather, which is a system which is able to collect data through a sensor, store the data collected both on a local database and also on the cloud server, and is able to display data through a personalized website. On the system design, we agreed that it should include the IoT sensor, the IoT gateway, and the IoT platform. On the IoT sensor that we agreed to use is the BMP180, which can measure both temperature and altitude. The IoT gateway, that is Raspberry Pi 3B Plus and Arduino Uno, are the two boards that we'll be using. On the IoT platform, we have the hardware side and the software side, and because of time, I won't be taking you through the whole thing. And the estimate cost of the project is 9,045 shillings. Now let Hampton take over from there and explain the implementation of the program.
So we do have the BMP180 on the first image. Secondly, we have the Arduino on the second image. And thirdly, we have the flowchart diagram for the Raspberry. And finally, a full setup of how we believe the system would look like. So I'll go straight into how it works. So the BMP180 collects the raw measurements. Arduino defines which pin is to be used by the pressure sensor. Then it is configured under serial communication and asks the BMP180 for the data collected. Raspberry now defines a serial connection speed and asks Arduino now for the data that was previously collected, which is now stored on our local server, that is MariaDB. We will create a web page through our Apache web server and will be scripted using PHP. And we'll also have another Python program that allows us to collect measurements, put it in a reserved log file, and then we can be able to modify some code which allows us to refresh data according to a certain moment of time. So for the end result, we do have display and storage. So we do have a template of how we want our display to look like, and this would be how we want it. Then we do have the local storage or the local database, and we do have an admin side where all logs are put into, or the log files that we had talked about earlier. So for our future works is basically to connect other sensors to measure other weather elements. That would be rainfall, temperature, the air quality, then also put in a buzzer and a micro camera. These are just security features after we have the full weather station implemented. We also have the expansion of the website with a live feed camera that the Dr. Sharon Jones could be able to view, probably if she's interested, to view who was where and who is doing what. So it just acts as a part of evidence. So since the other station is bound to be expanded, use of solar panel is also a good source of power to also reduce the cost. This would be our references, and our group members are Edwin Ramogi, Brian Kipto, Brian Ofula, Hio Hidbo Moses Munyingi, and I am Hector Kajiri from Bright Minds. Thank you.